Hello students, welcome to the class. In this class, we are going to start with theme 2, unit 1, talking about why do we need a standard scale or unit for measurement. Now students, when I talk about measurement, it is the integral part of our day-to-day life. For example, we keep on measuring various quantities such as height, weight, volume, mass, and so on. Now, when I talk about measurement, you might appreciate this that we measure lots of quantities around us. But what are these quantities? In physics, we refer to any quantity that we can measure as physical quantities. So, physics refers the quantities as physical quantities, right? Now, when I talk about physical quantities, we have to know that how we measure them. So, measurable quantities in physics are termed as physical quantities. We measure them by comparing them with a known quantity, right? So let's say if I say that my height is around 5 feet 6 inches, it means that I am 5 times of a foot, right? Similarly, if I say that the table is 3 meters long, I am comparing it with a long length of 1 meter, and it will be 3 times of that 1 meter. Hence, when we talk about measuring different things around us, we are talking about comparing it with the known standard quantities. So, the known standard quantities, as you can read here, are what? Are called the unit. Right? So we will read this out, just what we have written here. First thing is, any quantity which we study in physics is called what? It is called a physical quantity. And measurement of a physical quantity means comparing it with a known standard quantity. Each accepted standard quantity is standard to the measurement, and what we term it, we call this as a unit, right? So let us understand how did we come to this units and why cannot we have make our own units for different objects. For example, let me give you a very simple example here. In earlier days, people did not standardize the units. They used to measure different objects according to their own understanding. For example, let's say I have a table in front of me and I want to measure it. Now, today we have standard units, but in early days, what people used to do? They used to make use of their different body parts. For example, the outstretched palm, a foot, or even an arm or cubit. So what they used to do, let's say they have to measure this table, they will start from one edge and keep on measuring how many palm lengths are there for the table. But there is an issue with this kind of a measurement. Though this will give me, okay, this might be 10 palm lengths or it is around 2.5 arm lengths. But the issue with this was that each person's palm were of different outstretched length. For example, if I try to measure this table's length, it might be around 10 palm lengths. But if I ask a 6th standard student to start doing the same thing, you definitely know that your palms will be smaller than my palms. So it might take around 15 palm lengths. Then what will be the length? It will be very confusing. One person will give the answer, the length of the table will be 10, but the other will say it's 15. Both are correct for their own respective or perspective, but in standard, they both are not giving me the apt answer. Even in earlier days, king used to tell different kind of rules for measuring the length. For example, King Henry I once declared that the distance from the tip of his nose to the stretched thumb of his sideways. So, if you take your nose as the first point and stretch your hand till the tip of the thumb, You stretch your hand till the tip of the thumb till the from your nose is what he called as should be the unit of length. Now again the same problem will be there. Everybody cannot go to King Henry and see that okay, this is the one length, this was not standardized, but as he was king, he made this as a rule that 1 unit of length will be the length of his arm, his outstretched arm, from the tip of his nose to the tip of the thumb. Now he even called this with a new name called a yard, and you might have heard this term used in layman terms, right? Now such units cannot serve as standard for measuring length. The simple reason what? Because they are going to be different for different people. So as we can talk about it, if I give you the simple activity to measure the length of your sofa set or your bookshelf, even when I ask you to measure this with your outstretched palm, that is the side of your bed, and you ask the same to do for your mother and sister, and then you try to figure out whether all the lengths are coming same for your outstretched palm by tabulating it in the table, do you think you are going to get the right answer or similar answer for the least? The answer will be no. You guys are not going to get the same values, and this is the very reason that we need a standard unit, that everyone, if the 3 different people are measuring the length, it should be coming out the same answer. The length is not changing. By using different people or different processes, the length should not give me a different answer for a given object. Hence, the standardization of unit was required. And when we talked about the standard unit, we have to understand what do we mean by this. So a unit which is accepted by majority of the people as the basic unit of measurement is what we call as a standard unit. Now what we are saying here, when people figured out okay, there are lots of issues coming in measuring the different measurements or physical quantities with unstandardized units, it was not giving us the right or the similar answer, then in that case what should we do? So majority of the people agreed with this, that whatever unit we decide, it should be followed universally or everywhere. The length should not change from place to place or person to person. That unit is what we call as the standard unit. Right? Now the scientists all over the world have accepted a basic set of unit for measuring the basic physical quantities. Now when I talk about physical quantities, I told you that anything that we measure in physics, we term it as a physical quantity, right? Now when we talk about basic physical quantities, we refer to those quantities which are basic or which are used in our day-to-day life, such as mass. We measure mass of various objects in our day-to-day life. When we go for grocery shopping, we buy it by mass, right? So give us 2 kg of food or 2 kg of sugar or 1 kg of apple. Then length. We measure height, we measure the distances, all we measure is length. Time. Our 2 periods are some time difference apart. We always try to measure what is the time elapsed when one class starts till the time the next class get started. So we always measure time. And temperature, you might have seen in the newspaper column, it's always there, what is the temperature of the city or the state you are in, or when we get a fever, we measure our temperature. So these are the basic physical quantities that we keep on using in our day-to-day life. So what will be the units of these basic physical quantities is what is important for standardization. So this set of units which we have fixed for measuring these physical quantities is termed into a system or a group of these quantities. Group of these units that we put as standardized units is termed as Standard International System, or which is abbreviated as SI. What does this stand for? The Standard International System of Units. It is generally referred as the SI system of units, which take care of the standard units, the units which are followed universally for different physical quantities such as mass, length, time and temperature. Right? Now note something very important here. If we talk about the standard units, the unit of the physical quantity should be have the following characteristics. So there's something that is very important that we should keep in mind while picking up a unit to be standard. First point, it should be a convenient size. Now, what do you mean by this? If I talk about certain units which do not give me the value in whole numbers but in decimals, will it be convenient for me? No. Or if I say, let's say I decide a unit for measuring the length to be SI unit as kilometer. Now, how many distances do we see around us in our day-to-day life to be in kilometers? Only when we measure the distance between states or cities, we do require kilometer. But if I say what is the length of the table, kilometer will not be a good choice of standard unit. So standard unit must be convenient in size. It should not be too large or too small. Convenient means it should fit in to the most of the objects around us. If there are distances or lengths greater or smaller, we can always have multiples and submultiples, but we should keep one standard unit which should not be towards the greater side too much or towards the smaller side. It should not be on the extremes, right? Second, its value, that is magnitude, should not change with respect to place and time. So when we talk about standardization, that is one of the requirement. It should not be changing from place to place. Somebody who's measuring the length in India or somebody is measuring the length in UK should not be different because the place change. The length unit should be common, that is standardized, right? Neither the place nor the time, doesn't matter I measure the length in the morning or in the evening, the length should not change if it is standardized. Moreover, the people, it should be one unit that could be followed universally. So a measurement of physical quantity is made up of two parts. Something very, very important that we should note here, that whenever we measure a physical quantity, we need to take care of two parts in this. For example, let's say I'm measuring the length, or let's say even I'm measuring the distance between Delhi and Dehradun. Okay, now it is approximately the distance between Delhi and Dehradun. These are the two cities in the North India, is around 243 kilometers. It's around 243 kilometers. Now, if I only write, I ask somebody what is the distance between Delhi and Dehradun, and that person only replies me 243. 243 what? 243 kg, 243 centimeter, 243 centimeter square. What is it? I don't know. Okay, so somebody got it? Ma'am, wait. The answer would be 243 kilometer, right? Point number one. Second point, if I ask another student and he said, okay, kilometer is important, na ma'am? The answer is kilometer. But how many kilometers, that is missing? Even that will be lacking the information which is important. So when we write a unit, something that we need to note here is what? That there are always two important parts of the unit. One is the number that we refer as the measurement to be the magnitude. What is the magnitude of the distance between Delhi and Dehradun? It will be 243. But what is the unit or what is the distance? I have to mention it as 243 kilometer because the other person doesn't know whether I'm talking in meter, centimeter, millimeter, even bigger units. So the two important part is, one is magnitude, the other is the unit itself, right? So whenever we refer to any physical quantity, the two important part is magnitude and unit. So this is what is written here. A measurement of a physical quantity is made up of two parts, the magnitude and the unit. Now, an example is also given here. If the length of a park is 200 meter, then 200 is the number, is the magnitude, and meter is the standard unit. So this is something we need to keep in our mind, right? Let's go forward and understand standard units of length. Now, when we talk about standard unit of length, we have chosen according to the SI system. The chosen standard unit of length is meter. So the SI unit, when we measure length in its SI unit, we measure it in meter. In short term, we write meter as M. Hence, you might have seen most of the places it is written as, let's say, 10 meter, 20 meter, 30 meter. I can tell all of these are length because the unit in front of them is what? Is the standard unit of length, which is nothing but meter, right? The other part, the numeral part, is what, students? It is called the magnitude of the length, right? Now, the definition of meter is very, very interesting. You might be thinking, who decide what the meter should be or how long a meter is? So if you want to know, it is a very interesting thing that there is an organization definitely put into use to tell us what are these standard units equivalent to. So to define it, it is the length, because we measure length in meter. So meter is defined as the length between two fine marks on a metal bar that is made out of an alloy which is called platinum iridium alloy. This bar is maintained at a constant temperature and is placed on two rollers, which is kept in Paris in France. Can you think about it? This is so interesting that we take the standard unit by taking an actual, a physical platinum iridium alloy. The length of this is considered, the length of this which is kept in Paris, that is kept on two rollers, that it will not move anywhere else. The length of this long rod is told to be of 1 meter. Now to define it, 1 meter is 1/10 millionth. What does it mean? 1/10 million means 1 upon 1,000,000,000. So 10 million, 1/10 of a millionth of the distance from equator to the North Pole. So we all know our Earth has different longitudes, right? Now these longitudes, the center one is your equator and North Pole is the tip of the, from where the axis is passing. So if I figure out what is the distance between North Pole and the equator and I find 1/10 millionth of the distance from equator to the North Pole along the longitude passing through Paris in France, we say that this is the equivalent of 1 meter. You understand how much of research goes into defining such standard units, right? Now, as I told you, we have defined the standard or SI unit of the length to be meter. But what about the length when it becomes the distance between two cities or let's say even two countries? Do you think meter will be an apt unit to use? Let's take an example. Here is the example given where the distance between two cities, that is Amritsar and New Delhi, is given, and it is given to be in its standard unit, that is SI unit, meters, around 470,000 meters. Isn't it too big, right? It's like ones, tens, 100,000, 10,000, lakhs. So 4,70,000 meters. My goodness, somebody will never travel from Amritsar to New Delhi or vice versa. But this here seems to be a bigger number because we are measuring it in the SI unit. But when we talk about bigger distances, such as the distance between states or cities or even countries, we shift from meter to a bigger multiple of meter, which we call as kilometers. Where 1 kilometer is how much? It has 1,000 meters. Now, once we figure out, okay, 1 kilo means 1,000 of meters, it becomes convenient to give the distance between these two cities, that is Amritsar and New Delhi. What is it? It becomes 470 kilometers, which is now seems to be approachable, right? So a meter is not a convenient unit for expressing long lengths. For example, the lengths between two cities, states or countries. For that, we use a convenient unit which is kilometers, where kilo stands for 1,000. So 1 kilometer is equivalent to 1,000 of meters, right, students? So here what we are talking about, we are actually understanding that, okay, we have standardized the unit, but if we are going to measure bigger lengths or bigger distances, we can go to a bigger multiple of the standard unit, which is kilometer, which is defined as 1,000 of meter. Now, something more interesting is there. As we have multiple, we also have sub-multiples. For example, why do we need so? We have already defined meter, but there are quantities around us which is so small to be measured in meter. For example, I have a pencil. Okay. Now, if I have a pencil and I ask you what is its length, if you start telling me its length in meters, your answer will come around, let's say 0.15 of meter or 3/20th of a meter, which is too small, isn't it? So even for measuring smaller quantities, which is not apt to be measured in meter or very less or very small to be measured in meters, such lengths which are inconvenient to express in meters, we use a sub-multiple of meter, which is centimeter. Its short form is what? Its short form is given to be C and M. Right? Now, how much is 1 centimeter? It is 1/100th part of a meter. So, if I define 1 centimeter, it is 1/100 of meters. That means I can write 1 meter to be equivalent to 100 centimeter. Isn't it, students? So, something interesting that we are learning here, though we have defined standard unit or standard unit of length to be meter, we can always define multiple as well as sub-multiple depending on what we are measuring. So, 1 centimeter is 100th part of a meter. In other words, 1 meter is equal to 100 centimeters. Right? So, we will remember this very well. So, students, when we talk about measuring lengths which are even smaller than that of a centimeter, then what should we use? For that, we use the even smaller unit called millimeter. Now, let's do a very interesting thing here. Let's say I have to measure the thickness of coins, right? Now, when we know a coin will have its thickness even less than a centimeter. So, we were talking about some multiples of meter. So, let's say I have a 5 rupee coin and this coin is to be measured for its thickness. Now, if I measure this thickness in centimeter, even that will be very, very small. So, when we talk about how to express such smaller units, we use even another sub-multiple of meter that we call as millimeter. Millimeter or abbreviation as mm is what we see as the unit which is equivalent to 1/1000. That is 1,000 part of a meter. That means a meter has 1,000 millimeter in it. So when we talk about how do we define a millimeter is 1,000 part of a meter. That means 1 meter is equal to 1,000 millimeter. So when we have to measure the thickness of very small quantities such as the thickness of a coin, we neither use meter nor the centimeter, rather we go for even a smaller submultiple of meter which is called millimeter. So what we have learned, to sum up all the different quantities, we figured out that when we talk about the submultiples and the multiples of the standard unit of length, that is meter, we see that 1 meter is 100 of centimeter. 1 meter is 1,000 of millimeter. So can we find a relationship between 1 centimeter and millimeter? It is going to be around 10 millimeter. That is what we have written here. 1 centimeter is 10 millimeters, whereas 1 meter is 100 centimeter. And if I go to the multiple of meter, that is 1 kilometer, it is equivalent to 1,000 meter. Now, something very interesting is given here. Let's say I am given something in kilometers and I have to find it in meters. Then what I have to do, if I have to convert the unit from kilometer to meter, I have to multiply by 1,000. But if it is the other way around, I have to convert meter into kilometer, I have to divide it by 1,000. For example, 10 kilometers in meter will be 10 into 1,000, which is going to be 10,000 meters. But On the other hand, if I say 10 meters, how much kilometers are there? I have to divide it by 1000, which will be 0.001. Is it? No, it is going to be 0.01, right? So it will be 0.01. That is going to be the value of 10 meters. Similarly, if I have to convert meter to centimeter, I have to multiply by 100. But if I have to convert centimeter to meter, I have to divide by 100. Taking an example, again, 10 meter in centimeter will be 10 into 100, which is 1000 of centimeter. But 10 centimeter in meter will be 10 by 100, which is 0.01 meters. 0.1 meter, right? Now the last one, centimeter to millimeter. If I have to convert, I have to multiply by 10. For example, 10 centimeter will be equivalent to 10 into 10, which is 100 millimeters. But what about 10 millimeter? How many centimeters are there? I have to divide it by 10, which will give me what? 1 centimeter. This is what about all the multiples and submultiples of standard unit of length, which is meter. Now let's talk about this very interesting thing that we all people own. What is this? This is a ruler, and all of us in our geometry boxes, we definitely have a ruler. So when we talk about measuring the lengths with the ruler, if it is the ruler that is found in our geometry boxes, its total length will be around 15 centimeter. You might have checked that it has 15 divisions on it. But if I talk about the standard unit, we know the standard unit of length is meter. So how big or how long is a meter? A meter is as long that if we see 15 divisions on our ruler or the scale that we use from our geometry box, on a meter scale there will be 100 division. Each division will be equivalent to 1 centimeter. So you can note here, this each is equivalent to 1 centimeter in length. Now furthermore, you can even see that there are different divisions marked in between those 1 centimeter. What is this equivalent to? Each division here is equivalent to 1 millimeter, because we know 1 centimeter has 10 millimeters. So in between 1 centimeter, if we mark 10 divisions, we are actually marking each division for 1 millimeter. So hence we see how a scale can be put into use. Now talking about standard unit, we already learned for length we use meter. But there are other systems other than SI where we use different units for standardizing length. Now these units, though not the standard unit, are still in use at local areas. For example, in UK, foot along with inch is also put into use to measure length. So is the yard and the mile. Now you guys might find this fact very interesting that if I talk about what is your height, we do not measure our height in meters. We rather use feet and inches. So if I say I'm 5 foot 6 inches, I'm measuring my height, that is the length, but not in meter, rather in foot and inches. So that is what in UK or UK system generally go with FPS. What does this FPS stand for? The F stand for feet, the P stand for pound, that is the unit of mass, and the second stand for S stand for second, that is the measurement per time. So in the UK system, the foot along with inch, yard and mile were officially started as the primary units of measurement for the road signs and related measurement of distance and speed. The foot was also used globally to measure the altitude of aviation industry. Now this is very, very interesting. As I told you, we still use this foot and inch for measuring our height. Rather, this is the same foot that is put into use for measuring the altitude. That means how high a thing is flying, that is in aviation industry. Rather, even for measuring the peaks, the mountains, the range, how high the altitude are, we again use foot to be the unit. Now the foot, as we already talked, is the base unit in the FPS system for measuring length. where mass is used for pounds and seconds for time. So to derive other units, we use this FPS system as well. The FPS system has largely replaced by SI system, based on which we measure the quantities such as the length, the mass, and the time in meter, in kilogram, and in second. So this is the SI system, that is standard. On the other hand, in FPS, if I measure, the length is measured in foot or feet, mass is measured in pounds, and the time is again measured in second, right? Okay, so if we are clear with this, we can furthermore interest ourselves to understand how the standard unit and the FPS is related. So when we talk about how big or how long is an inch, we can tell this. An inch is the unit of measurement in the American standard of measurements. Okay, so how much equivalent is 1 foot? 1 foot is equivalent to 12 inches. So there are 12 inches in 1 foot. Now since 1959, the inch has been defined as 1 inch is defined to be 2.54 centimeters. Right? Now if I tell you what is the symbol of inch, it is written as inch. Or if you have ever seen what is the height written as, the height of a person is written as, let's say, 5 feet 6 inches with the apostrophe sign and double apostrophe. So this is what is 5 foot 6 inches, right? Now a foot, as we were talking, which we say for plural, so here it should be 5 feet 6 inches, right, which is the plural, is the common length unit in imperial system and the current US customary unit system. So US still put into use the foot and inches to measure the length. How much is 1 foot equivalent to? 1 foot, which is 12 inches, is furthermore equivalent to 0.3048 meters, right? 1 foot is 12 inches, and that makes 3 feet to be equivalent to 1 yard, right? So we mention this as either 1 FT or with an apostrophe, right? So people, what did we understand? Though we have standard system now, but still locally, let's say in UK and in US, following the imperial system or US customary unit system, they still put into use the units for length as feet and inches, right?